All right, so we need to discuss seaborn today. So let me take a data set. First of all, we need to import few things, right? So import number something, import pandas, speedy, import matplotlib, plot as plt, import seaborn as SNS. So SNS is the usual alias that we use. Even documentation, you'll find the same alias, but you can use any alias you want. And let me load the data set. I think I have it right here. So, yeah. I have taken iris data set and we will plot one after another. So start with bar plot. Bar plot. Let's see what the documentation says. Is basically it's we need to provide two things, right? Data, DF. I think it's right. Yeah. So usually, typically, it's going to be like this. Not all, but data, x-axis, x variable, and y variable. That is how the typical, the graph is going to be. So I'm going to provide x-axis space, sepal length, and petal length. Let's see, okay. So I'm going to provide x equal to y equal to. I can see a bar graph between sepal length and petal length, right? So of course it can be anything in between sepal. This is a bar plot, right? The next one, I hope you understood what is bar plot. Basically, we need to provide the data frame and any the usual bar plot. If you want to plot between two columns, this is how you can do it. Of course, the graph is bit crunched down, right? So what we can do is we can use matplotlib to fix that issue. So we have fixed size. Let's take 8,6 and fig is actually we need to provide access. Maybe can it for is much better, right? So let's say 12 is much better. So we can use matplotlib to customize this. It is not that see we can't do it in Seaborn. We can do it in Seaborn, but it's better to use matplotlib, right? You will see some information like this. So if you mention pl.show, that is going to remove that metadata, right? Any questions on bar plot?
Sir, what is that fig comma? Can't we just use ax is equal to?
Uh, Actually, this subplots is going to return two things. One is fig, is going to be a structure. It's like the skeleton kind of. Axis is going to point out the exact axis related information. X-axis, Y-axis information. So it's going. This subplot method itself is going to return two. If you don't want this, then anyway we are not going to use it. So you can use underscore. That way we can avoid that. Right?
Okay.
Next one is count plot. Iris, let me take iris DF, right? Species. Suppose if you want to get the count, so we use value counts, right? So this way we can get the value count. Suppose if you want to plot a bar graph, bar plot, on top of this. So we can do that, but we need to reset index. We need to get in the form of data frame. It's now in the form of series. Now we have the data. So we'll do one thing. So we will make it as data. Now we can bar plot. Data is data, right? Here the data is the parameter name and data here is the argument. It can be any other things. Data one, if you mention data one, then you need to provide data one over here. And it is in between species and count. So x equal to species and y equal to count. Now you got the graph, right? Because pl.show will suppress that message and I will copy this one to make it better. We have something called AX so that it is going to consider this AX. It's not really necessary to have that. Yeah, this is better. Right? So this is how we can get count plot. Basically, this whatever we get through value counts, which is going to give the frequency, right? Frequency of that particular value. So species is going to have three values: setosa, versicolor, and virginica. By this, we can say that setosa is, it has this particular column, species column has 50 values of setosa, 50 values of versicolor, and 50 values of virginica. And this is the visual representation of the same thing. And in fact, but we need to do all this stuff to get this thing. So instead, what we can do is I'm going to use the data frame directly. Instead of bar plot, I'm going to use count plot. Count plot is very much like value counts method. So internally, it's going to do value counts. So species, and in fact, we don't have a column like count as such. What is okay? Let me take off this. Check the document data. X is okay. I think somewhere okay. I think I missed the comma part. Yeah. Now the same thing. Yes, right away I provide the data frame and the whatever the space column I want to get the count. I mean to say frequency, and I got the result instead of doing all this stuff. So bar plot is not going to do count, whereas count plot is very much like value counts. It is visual representation of it. So you can either use this or use this. This is much better if you want to get the frequency. It's straightforward, right? Any questions on count plot?
No. Sir, if you want to see like the data is 50, right, for the three of them. So if it
Okay.
was 49, 51 or something other
Hmm.
than the round of numbers, so is there any way to represent in the bar graph itself
That
inside
is
the field?
that is what. So if you have this, you can see that here you have. I think there should be uh, right now we don't have an option here, but we can look at this way. Usually, if we have more sophisticated tool like Tableau and Power BI, we can get the count on top of it, right? But
Yeah,
here we
yeah.
need to look at this. So I don't see any option that gives annotation. So or else maybe I need to read the documentation for it. But don't expect as much as you get it in Tableau or Power BI. That is for sure.
Yeah.
Usually, like if you gain 1 or 2 years of experience, you're not going to use this one. Instead, you better use this. You're going to use this one. Visual representation may look maybe fancy, but it's not required all the time. So we can manage with this one. If you want to check the counts, which one you prefer with this one or this one? I mean to
This
say this one
tabular
or
form. Yeah.
Tableau form, right? So if you even template, you're not going to see any visualization because AI is different and data analysis is different. Data analysis is part of AI. We need to understand the data. But the data analyst, what they do is they prepare dashboards in a way that management can understand. So someone else can understand, someone else can interpret. That is different. AI here is we need to understand the data so that we can pre-process it, clean it, that we can feed to the algorithm. So the purpose is different. But again, as I told you, visualization, it's your choice, but it's not must. We
Okay, sir.
have, no, it's better to write methods. So here we can even filter the data frame if you want later, right? If you have too many. All right. So the next one is box plot. This part is going to be quite interesting. But the interpretation, exact interpretation, you might have seen it in df.describe, right? 25% minimum, 25th percentile. This is percentile. Don't read it as percentage. It's difficult to it's write percentile, right? That's the reason they give percentage. 50th percentile, 75th percentile. 50th percentile is nothing but a mean or median. Okay. So these values max, we can get it in visual form using box plot. Let's see how do we get that. The box plot, sorry, data equal to def. So by default, if you apply it on the whole data frame, you're going to get for all, right? If you need, just like the way we got on describe, so we got for all the columns, right? If you want to get on a specific column, we have, you can see that we can get it. If you want it in a vertical manner, use Y. Okay. But in this case, I want, it's fine to have for all the things. Um, the only thing is when you have too many columns, then it's going to be quite murky. Again, as I told you that visualization at some extent, it's going to work, but it's better to rely on these sort of methods to get information, the appropriate information. So any questions on this? Basically, let me explain this. So these are outliers. These dots are outliers. This part is this line, all right, underline. This line is minimum. This line is maximum. These are outliers. These dots are outliers. And this middle line in the box is the 50th percentile. That is median or mean. And this part, you can see that is 75th percentile. This is 25th percentile. 25th percentile, let me read this. Outliers, minimum, 25th percentile, 50th percentile, 75th percentile, max, and again outliers. That's how it works. That's how you need to read.
Sir, what exactly it is inference means? Give that information, sir, here. Means minimum, maximum, and
Right. The minimum value in that particular column, maximum value in that particular column, 25th percentile, 50th percent, 75th percent. Again, I will explain this in statistics. Usually,
okay.
minimum value in the sense when we sort it in ascending order, the first value is going to be the minimum value. The last value is going to be the maximum value, right? But that is not how we do that. Let me show you. I think I don't have this. Yeah, here we have. The explanation part, I will explain it later. Maybe I think I already have. Where is that? Okay, so here. So when we take the data and I'm going to explain Q1 is nothing but 20th percentile, 50th, 75th percentile. So we are going to calculate the minimum and maximum value later. So I will explain the concept later. This
Okay,
is
sir.
only to, but if you don't understand what this 25th percentile, that's fine. But where do we look at these values? This is how we can get it in visual form. But in
Sure, sir.
numerical form, this is how we get this df dot describe. All right. So there are alternatives for the same box plot. There's something called violin plot. Okay. There is something called a swarm plot. Okay. Let me press warnings. All right. So just by looking at these three plots, what do you think the difference between these three? It's actually the same thing. Okay, same information is going to give. What do you think the difference between these three?
Sir,
Representation. I mean,
uh, below one, it is showing more property distribution of the data. It is
Oh, so it's not showing up here, and it is not
here.
showing
It
up
is
here.
but easily understandable in the box plot.
box plot.
Box plot, you can easily
We can
understand.
easily understand. Yeah.
Yeah.
But he brought a new point. So the distributions. So do you think that we can understand distribution of the data? We have
Here it
y-axis.
is
No, no,
not.
no
No.
distribution. No.
No
So,
distribution we can understand.
so we can understand distribution by these two things, right?
Yes, yes. That's true.
Right. But can we understand outliers here in these two?
No, no. I
But we can
mean,
easily understand
for
outliers
specific
here.
purpose, we are using the graphs based on that.
Yeah, we can
Yes.
easily understand this from here box plot, right?
Yeah, yeah.
So, but every visual representation, every plot has its own plus and minus. If you look at this one over this one, it's in fact the same, but it is going to give the data points. If there is any gap in between this, we can easily find it out. But whereas in this one, we are not going to see that. Of course, again, as I told you, being an AI or machine learning engineer, you're not going to rely on this visualization, but it's going to give a gist of it, like how the data is going to be. Even from being a beginner, you need to understand these visualizations. You can see there is a clear gap between these two.
So there, every dot is a data, right?
Yeah,
In that
data point, data
form plot.
point. But one drawback in this is there is a possibility that it may be overlaid one top of another. So we can't say just by looking at this and counting these dots say that this many rows we have. So there is a possibility that there are duplicate, there are same values and it's going to be overlaid one top of another, right?
Yeah, yeah.
All right. So
So in the
we,
violin plot, it is to get the average or something. I mean, there is a white dot.
it's the same box plot, but is going to give us the distribution apart from what we don't see it. I mean, same box plot, but it's going to give distribution, whereas box plot does not give distribution. But again, the minimum outliers is difficult to interpret, whereas minimum max also you can clearly distinguish. What happens if you plot the two plots? Actually, by default, it's going to overlay, right? Here is giving the same information, but is giving same color. So what we can do is color, going to make it as black. I think it's better to, can we make like this? No, this is much better, right? And of course, the size is a bit different. We need to expand it. We'll do one thing. Uh, all, all, maybe 6. Much better. We can see that now. So we can plot one over another. This is the default behavior. If you plot two graphs at a time, it's going to show up like this. As I told you in yesterday, in Matplotlib, I think I explained it. If you want this to be as two graphs, then go for this, right? One next to another. Thing is because of access. By default, it's going to apply. So I'm going to, now you can see that. And it's applying this plot stuff only to this one. So what we can do to solve that is one here, two here, x equal to x 2, and x equal to x 1. Now you got it, right? But usually in sort graphs, it's better to go one. I mean, instead of having it here, it's better to go with another block altogether, right? So not to fit everything into one.
The same techniques that you used yesterday to plot the graph side by side, 1, 2. The same can be used here to get
Yeah.
that representation.
Yes, we can do that. The same thing. Let's take let's take 1, comma. Maybe in this case it's 2, comma 1 better. 2 rows, 1,
Yeah, one.
okay. 2 rows, 1, comma. But the data is going to be all right. So we'll try this. Let's see. In this case, 2 rows, 1 column means what? So 2
One
rows,
upon another.
1 column. So it's actually 0, 1, 0. So this is going to be 0, comma 0, 1, comma 0, right? So x 0, 0, comma 0. Let's see whether it gives, but 2 were indexed. All right, so let me get this up. Yeah, I'm straight away giving 0 and 1. Maybe that is how we read it anyway. And what is the other plot here? So it's volume plot. So axis 1, right? We can get it. We can do that. That's 1, comma 2. We need to change it accordingly.
So figure size also need to be changed then.
Right. So it's not necessary that you have to have in this form. And moreover, you can see that this is much better compared to the previous one. 1, comma 2 I have made change. Right?
Yeah.
All right. So any questions on box plot, volume plot, swarm plot? Of course, overlaying plot. Overlaying plot is nothing but one in we have seen, right, one top of another kind of. So the exact 25th percentile explanation, I will explain it in statistics. The next one is distribution plot. This is very important, and it is difficult to get a right method to get distribution. So visualization perspective, this plot is very important. So pay attention. SNS.dist plot. Let me check what we have here. Do we have data? So I don't think we have data here. All right. So DF petal length. By the way, distribution plot is univariate. Univariate means only one on one column. It's going to give us distribution in the data. You can see that the way it has been distributed. So whatever we saw in volume plot, we're going to get similar to that. But that is more of smooth curve. Whereas the exact histogram, exact frequency, you can see it here. So between 0 and 2, there are somewhere around No, you can see that around 0.25 or 0.5, whatever. These values 0.25, these values are basically like around 2.
Yeah, I can put a marker, I think, right?
Yeah. And this one, and so there are a few other options here. I'll do one thing. I will try to make it for all. There are 4 columns, right? Petal width, sepal length, sepal width. As everything being clubbed, so we can use pl.subplots to draw it better, one next to another. I will make it 1,4. Fixed size, we'll see that later. The score AX, right? We need to provide AX 0. This is 1, this is 2, this is 3. Let's see how it goes. Yeah, we got the one, so not show. We'll take off this. And the size is bit concerned, right? So let's take 12,4. Maybe a better option. It's much better, isn't it? So this distribution plot, it is difficult to get, in the form of, it is better to get it's almost impossible to get an alternative method, to see it in numerical form. So when it comes to plots, this will be, plot that you have to use. You can't avoid this, right? It is going to give the exact distribution of it. So there is something called, okay. You have seen it, right? A smooth curve, it's actually, this one is a histogram. So if you want to suppress this, you can suppress it. So you can see that you're not going to see any histogram here. Let me copy this.
The background blue color graph is the histogram. That's what you're telling.
Yeah, that the bars, you can see that, right? Basically, those bars are histogram. Histogram means, suppose if we have, right, if we have data like this, we need to get the frequency. 1 is repeated 3 times, 2 is repeated 2 times, 3 got repeated 4 times, 4 got repeated 2 times, 5 is repeated only once. So if you plot a graph on this frequency, what are these values? 1, 2, 3, 4, 5, right? So 1, 2, 3, 4. It can be y-axis or x-axis, again, the way we saw this. So the frequency is going to be, let's take 1, 2, 4, or whatever, 5. So 1 is how many times it got repeated? 3 times.
3
Great.
times.
2, how many times it got repeated? 2
Right.
times.
2 times.
3, how many times it got repeated? 4 times.
4.
So 4, how many times it got repeated? 2 times. And 5, how many times it got repeated? Only once. So the curve, that smooth curve you see, that is going to give us like this. But the actual data is going to be, it's going to miss this sort of things. Or sometimes it may give information, but we can't completely rely on this curve, this smooth curve distribution.
So
Distribution
we need
curves,
histogram.
yeah, we need to understand, we need to check both, so that you
It's
can
quite
get
similar to, sir, mode. I think through the mode, I think we can get that frequency.
mode is different. Mode is the most frequent value of all the data.
Third
All the data.
written.
It's not going to give for every value it has, right? Mode is going to be the most frequent value of all the data. It's going to give only one value.
Yes, sir.
I think this is because, so Histogram along with the smooth curve will help us the overall distribution and the actual pattern in it. And if you want to suppress this smooth curve that you see, we call it as kernel density estimation. You can even suppress that. You can see that you're not going to see the smooth curve, right? Kernel density estimation. You can suppress it now, but it's better to have it. Okay, so let's try that. You can see that this is pure histogram. And but I will make it true. I'm going to show you another option, an interesting option. Tell
What is
me
it? Kernel density?
kernel density estimation, which is nothing but a smooth curve. So it's a fancy word, but it's basically the idea is it's going to give a smooth curve how distribution has been, I mean, the data has been distributed. Now tell me what is that it is different from the previous one. I given something called rug.
Yeah, it's denoting that values on the
Yeah,
x-axis.
these are the actually data points, just like the way we got in which plot is that? Swarm plot, right? Swarm plot, Boolean plot, swarm plot. Swarm plot, we have data, we had data points, right? Same way, rug plot, rug true is going to give the data points, but again, it's going to be overlapped. So we can even clearly see that if it's overlapped, you can see very thick in nature. There is a gap over here. Clearly shows in the histogram also, right? So this is one plot that I know you have to use to understand the distribution. And how it's going to be useful, we will see that in, again, there are alternatives for this one also. We will see that in template.
Sir, one question, sir. Oh, sir, what do you mean by the smooth of the earth? Means,
Overall, just like on an average, how things are. So let's take that you start watching, someone is watching the game cricket match, and you ask him like, what is going on. Then it's going to give a smooth picture of it, an average picture of it, right? That's what it means. In
Sir,
distribute,
what if I want to add a marker on a single graph? Then I should add plt.plot of that one. I should add like that.
you can suppress it. You can customize it, right? Just one after another, right? You can, let's take that. I don't want rug here. I can make it. But if you want it only on one column, it's better not to plot on all, right? So you can do that stuff. Here I have given to show you that how subplots works along with Seaborn. Any questions?
No, sir.
sir, then, sir, in this four figure, which one I can say as a smooth of the graph? Means,
See, it's not smooth. I think you are literally taking smoothness. See, here we have peaks here. It got ignored, right? So it is giving us how the overall distribution is, but it's not the real picture. Yeah, the real picture is going to be given by histogram.
okay.
So you're comparing these three and saying which one is smoother. No, that is
Oh, no, sir. I asked. I thought that maybe.
no. All right. So there's something called LM plot. Again, this is regression related. We'll explain the concept later, but I will explain how to show it. So you have got okay. Um, LM plot, let's take x equal to sepal length, y equal to petal. Going to give us the regression process. Of course, these are the scatter plot. So we take each value from x and then sepal length and petal length. So wherever it's going to coincide, so that is what these data points are. And there is a line here. It indicates what is the direction in which these data points are moving on. You can see that it is moving towards up. Of course, in this case, it doesn't make much sense. But if you take financial data kind of, then it clearly shows us which direction is going on. If it is in this direction, it means that it is growing. But
Positive.
again, yeah, the sepal length, again, in fact, this data is also right for this one. So if sepal length increases, petal length also increases, right? So iris flower, it's all about iris flower. There are different various species in this. There are various species in this. Just by looking, by having data of sepal length actually the inside part, I think, if I'm not wrong. There are inside part of it and the outer part of it.
Sepal will be under and petal will be over that.
Okay. This is petal and this is sepal, right?
Sepal.
Okay. So this length is going to give length and width. Length and width. So if one sepal length increases, petal length also increases. That is what this correlation help us. And it's going in a increasing order. If the direction is, it is even giving the correlation, right? If it is like this, it means if sepal length increases, petal length decreases. If it is something like this, it is going to say if sepal length increases, there is no impact on the other one. It is even giving the correlation. In this case, data points are going to be somewhere like this. So in this case, it's going to be like this, right? I hope you got the point.
Yeah.
So this one and this there is a shadow kind of thin border kind of. I told you that I think yesterday I said it. So this confidence interval, there is a, you can see there's some shady part of it to the next to the line, left
Yeah.
and right. That is confidence interval. I'll explain that in statistics, advanced statistics. So just remember that when I say that we have seen, this shadow part in regression LM plot, you need to, you should be in a position to recollect it rather than showing it again, right? So the LM plot, this is one plot. There is another plot, a reg plot. Do you see any difference between these two? Do you see any difference between these two?
Quite similar, like.
Sorry? Yeah, it's the
No,
same.
it is quite exactly same like that.
It's not similar, it's exact one. It's in fact, LM plot and reg plot are the same. I'll explain the difference between LM plot and reg plot. When it comes to visualization, it is the same, right? So there are, like, let's take, suppose if I actually, this is basically between sepal length and petal length, right? But we have another column species. What if I want to get LM plot, I mean this regression plot for each of these species, I mean categorized based on species. Setosa is one part, right? And we have what do we have? Species Setosa, virginica, and versicolor, right? Obviously, each one has its own sepal length, sepal width, petal length, petal width. Setosa is one category. Virginica is one another category. Another, we have another category here, right? Versicolor. But this representation is for between these two columns for the overall without considering species, right? What if we want to have 3 plots for each of this category? Then we need to use something called facet grid. I think it has data. Yeah, data. And call is, we need to mention on which column we want to categorize. So I can give any variable I want. And in this case, I need to mention g.map. So map is nothing but a kind of loop for each of the category given in this column. We have it in that column. And in this case, I need to mention sns.regplot as a plots is going to loop and apply for each category of this. And sepal length, we don't require this section, right? You can see we got it for each of the category. This is for setosa, this is for versicolor, and this is for virginica, right? And what the point? So this is how we do it. But with LM plot, let me show you this. With one option here, as we got it in one itself. But if we need it in as three different plots, you can see that we can use call. So LM plot is in fact regression plot, the same plot, but it has more features, more parameters that we can tweak and get without, get the information without much complexity, like in this case. We can still do it using a red plot, but this is much better option. Got it?
So in the G.map, only that reg plot can be used, right? I mean,
you can use other plots, so it doesn't matter which plot you use. But in this case, I'm trying to show you the difference between red plot and LM plot. You can even use histogram.
okay.
All right, so I hope you got the difference between LM plot and red plot. Maybe this part is you may feel a bit difficult. So that's by practice you'll understand it. All right, so the next one is, I think these are the most easiest plots. So SNS or pair plot. I'm going to draw it on the whole data frame. Tell me what exactly it is trying to give. Whatever the information we have on, yeah, go ahead.
No, sir. No,
Go ahead,
no,
go ahead.
I have no. I am saying that there are so many graph has come.
Yeah, pay plot is actually we had drawn it against all the data frame, right? So that's the reason it's giving that way. We can even draw it between two particular columns, if I'm not wrong. Yeah, I think it's pay
I think
plot
it is taking every
yeah.
plotting that one.
Yeah, okay. So what exactly? Yeah, every column, of course, every column combination, sepal length, petal length,
Yeah,
sepal length is kind of correlation. You have seen it in this one, in pandas, right? So
kind of
this,
matrix kind of thing.
yeah. So what is
Yeah.
trying to give?
Sir, from this graph, it is showing that when sepal length increases, petal width also increases.
No, that is fine. The scatter plot, it is giving the these things, but what on overall, what it's trying to give?
Positive
This,
correlation is there again.
no, so basically this pay plot is trying to give scatter plot if it is some other column. Let's take petal length, sepal length. But if it is the same column, let's take petal width, right? Petal width. If it is the same column, it's giving histogram. If it is some other column, like it is giving every possible combination here. If it is some other column, petal width and petal length, or petal width or sepal width, it is giving scatter plot. So it's going to give us scatter plot in every case, except when it is the same column name, right?
Okay.
I mean,
Yes, sir. Understood.
last point I didn't understand, sir. It is going to give the swarm plot.
No, it's not swarm plot, scatter plot.
Sorry, scatter plot. But the box plot is
If it is the
the
same
bar.
column, it is going to give the histogram. You can see the diagonal one. Petal width, and petal width. Here is petal length,
Yeah.
petal length,
Got it. Yeah.
sepal width, and sepal width.
X-axis and Y-axis is of same parameter. Then it will
Yeah.
give the.
Right. Okay.
But on
So
that
this,
on that time, the value should be same. I mean, if the petal length and petal length, that is, if I consider one, then it is one.
the values is
So-
not, it's not, it should be same. Obviously the values are going to be same for the same column, right? But again, this is going to be quite cumbersome if we have too many columns. So again, as I told you, this is not really much of help. But distribution plot is going to be helpful. And even that we can write a code. So we'll see that later. So pie plot, I hope you got the point. And we have join plot. Again, I'm going to draw the one join plot data. You need to explain me what this gives us. Petal length. You can draw between any two things. What do you think that we got here? It doesn't matter which column these are, but basically what is trying to give us. Of course, this is scatter plot between sepal length and petal length, right?
It is giving that along with the distribution that one
Yeah,
on
it
the
is giving a histogram for each of these
that
columns.
histogram, yeah.
This histogram is basically for sepal length, and this histogram is basically for petal length. Its join plot is the reason why it got the name join plot is going to join the scatter plot and histogram. Okay.
So the histogram 4.5 is related. I mean, the sepal length 4.5 is that one. So in the petal length, how to read the values of the histogram values?
If you
The
really
sepal.
want to know the values, you can directly see the data, right? It's going to
Ah,
give us the overall picture. Visualization is not about precisely looking at the values. You can directly
just the
see the data
distribution.
from it. Yeah, it's going to give
Visualize.
overall picture. So that is the whole point.
Oh,
So DF, I'm going to, all right. So we have numeric only. We have df.core is going to give the correlation for each of this. Again, I will explain what is correlation later. So the correlation helps us in, if one increases, how much the other one increases. Let's say sepal length is the same column, so you can ignore this part. Sepal length and sepal, look at sepal length, sepal width. So it's basically when sepal length increases, sepal width in fact decreases at what rate? 10%, around 10%, 12%. So usually the correlation is going to be like this. When it is near to 1, it means strong correlation. Okay. When it is near to 0, it means weak correlation. There's no much impact. This one, right? Even though it decreases, but at a very less rate, right? And if it is negative, it is a negative correlation. So one increases, the other one decreases. If positive, if one increases, the other one increases. That is how you need to read this. By looking at these values, we can say, so what do you think that this is? Petal length and the petal, what it says?
as the sepal length is increasing, the
No,
petal
no,
length will also increase.
petal length and petal width. Yeah, this
Yeah,
value.
it is has a strong relation. I mean,
Yeah,
What does
both
that
of
strong
mean?
correlation.
Strong?
Correlation.
Okay,
No.
but
width
Yes.
also
explain it,
increases
explain.
as the length increases. It is telling that one.
So if petal length increases, petal width also increases at a rate of 96. That is positive
96.
correlation.
Oh,
So it's
96.
a
Okay. Okay.
strong positive correlation and it is increasing at a rate of 96%,
Okay. Yes.
right? Of course,
86.
definitely it clearly says that this is petal width is not going to be exactly as same of this, but it's almost near to it. I mean, in terms of percentage. But if you want to have a visual representation of this, we use heat map. We need to provide this. You can see that it's the same visual form. We need to look at this slider. So this is negative and this is positive. Okay. So this is 0. As we don't have anything other than beyond this minus 0.4, we don't have that scale. So blacker it is negative correlation. Light color it is light pink kind of, it is positive correlation, right? Red it is, so it's more of neutral kind of, right? And we have other options, like in this case we have a note. We can even see those values. I still don't know why some values being shown up and some values not. I think there is a bug in this one. So earlier we used to get that. Even format we can have it. Invalid format specifiers. Okay. There's a heat map. Oh, I think they had changed to G. Earlier it used to be F. It changed to G, it looks like. Not even that. Okay. Yeah, I think they made few changes. That's the reason it's difficult. Maybe again it's 0. Or maybe you can even adjust. Let's take 1. You can see there is only one decimal value, right? Let's take 3. It's going to give us 3 decimal values. If we give percentage, we used to get this one. If you want it in percentage, we can multiply these values by 100. Now this is percentage. Don't ask me why it's not showing up. I told you that it looks like there is some bug. It has to show all the values. Okay, that's it on Seaborn. Any questions?
So do you have to have knowledge on, deep knowledge on the visualization, or like just
Visualization will give us the overall picture of the data. Whether you want to have knowledge or not, again, it's your choice. Obviously,
so
yes, but
yeah.
if you gain more and more experience, you don't rely on this one. So let's take that same heat map. If you have 1,000 numerical columns, how do you interpret it? Obviously, that question rises, right? So
Yeah.
obviously, we write some logic, some function, some code to get what. No, we try to narrow it down. We try to precisely get what we need by methods. So more experience you gain, more you try to avoid. No, more you will obviously avoid visualizations. Visualizations are not really an ML engineer do.
So
It's
are we
more of
going
data
to
analyst.
do that one? Write the code as you told. Yeah. Will we
So
learn?
based on the need, like so value counts we have for instead of count plot, right? The same way for every plot, it has its own thing. So distribution plot, we have something called skew. So I will explain that in machine learning template. For again, this one correlation, I have written a function to filter out columns that has high correlation. So for everything, if it's required, I have an alternate method for it.
So in the histogram, wherever this graph is there, the darker it is, the negative correlation. That
So
is correct, right?
what is the need of bothering about? Just you can look
No,
at this,
just to know,
right?
just for the knowledge, I'm asking.
No. The scale you need to look at. So it doesn't mean the dark all the time it is negative. Again, that you
Oh,
should not get into that perception, right? So you need to look at the scale.
100% potential. Yeah.
Yeah.
Got it.
All right. Any other questions? There's some
No.
background noise. Please mute yourself if you don't have questions. Yeah, I think it's coming from Piyush. Yeah. Any other questions? All right. That's it for today. Thanks for joining.
Thank you, sir.
Continue on
Thank you,
Monday.
sir.
We will
Yes.
start mathematics and statistics. That is another important topic. Don't skip the sessions. Yeah. Thanks.
Yeah.
Yeah, sir. Thank you, sir.